For Module 5, Lesson 15 Problem Set, we are going to continue our exploration of finding common denominators to help us solve the answer. In our previous lessons, we have looked at how when the numerators are the same, we look at denominators that are smaller and recognize that even though we want a smaller number denominator to be a smaller fraction, it's actually a larger fraction. But one way that makes me feel more comfortable to know which fraction is less than, greater than, or equal to is to compare using like terms. And the way we do that is to find a common denominator. If I cut the same amount into the same size pieces, I'm going to be able to confidently identify which is more or less. So our directions say draw an area model for the pair of fractions and use it to compare the two fractions by writing greater than, less than, or equal to on the lines. The first two have been partially done for you. Each rectangle represents one. So this problem for the most part is already done. We have 1/2 represented right here, and we have 2/3 represented right here. And one of the things that we do first off is we look at these denominators to see what would be a common factor. And 2 cannot go into 3, but both fractions can go into 6. In our orange, we see that 1/2, in order to get from 2 to 6, we must multiply by 3. And if we do multiply by 3 on bottom, we have to do it on top. So the same value, 1/2, can also be represented as 3/6. And I'm going to kind of color that 1/2 amount in. If I'm looking at just this original, this large box would be 1 out of 2. But if I then break it into groups of 6, I can also see how that would be 3 groups out of 6 total. In our other one, we're looking at 2/3, and we're going to transition that 3 into 6. How do we do it? Well, we multiply by 2. So 3 times 2 is 6. Perfect. But in this situation, 2 times 2, right? We multiply by 2 here, so we have to multiply by 2 here, would equal 4. So I'll shade in. And actually, technically, if I'm looking at 2/3, I probably should shade this one and not this one. So we have 1, 2 out of 3 shaded, but when I compare and I cut them into 2 parts, I have 1, 2, 3, 4 out of, again, this one's not here, total of 6. And when I count these same size pieces, 1, 2, 3, 4 is larger than 3, which tells me that the original fraction, right, 4/6 is the same thing as 2/3, and 3/6 is the same thing as 1/2, which tells me that 2/3 is greater than 1/2, or if we're looking at it from left to right, 1/2 is less than 2/3. Moving over here, the only difference that they didn't do is they didn't tell us if it was less than, greater than, or equal to, and they didn't show the comparison of fractions. But I can see over here that this 4/5 is created this area model. So I'm going to rewrite this here, and I'm going to take that 3/4, and I'm going to write it next to the other area model. And what I'm going to do is I'm going to shade in now, this way I don't make a mistake. 1, 2, 3, 4. And this one, I'm going to color in 3. 1, 2, 3. I'm actually going to change pen colors. Let me see if I can find a black. In this fraction, I know that a common factor between 5 and 4 to get a common denominator, the first one we can come across is actually going to be 20. Now, how do I multiply 5 to get to 20? Well, I multiply it conveniently by 4. So 4 times 5 is 20. Whatever I do down here, I must do up top. So 4 times 4 equals 16. Before we go any further, I recognize that I now need to have 4 groups because I multiplied by 4. So now I have 1 row, 2 rows, 3 rows, 4 rows, and 5 columns representing this 4 by 5. So if I count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 16 out of 20 represented. Looking at 3/4. In order to get from 3/4 to 20, I need to multiply by 5. 4 times 5 equals 20. Which means if I do it down here, I must do it up top. So 3 times 5. Well, 3 times 5 is 15. And I'm going to go ahead and recognize that I need to break this into 5 columns. So now I'm going to count how many I have. And you'll notice that this one's more horizontal, and that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. When I look at this comparison fraction, the terms are the same, 20 and 20. 16, though, is greater than 15, which means the equivalent fraction of 16/20 is greater than the equivalent fraction of 15/20, which means that 4/5 is greater than 3/4. Let's look at one more. We'll look at this one. Now, I will tell you, in order to find common denominators, 7 and 6, you're going to really have to have a large area model for this. Same thing with 8 and 9. It's a slightly higher amount to represent that area model. But let's look at this 2/3 and 3/4. And I'm going to create a box for 2/3. And I'm going to create a separate area model. And my goal is for it to represent the same amount of space. I recognize that they are not perfectly sized rectangles, and they are not exactly even. Bear with me on that one, okay? So this one will represent 3/4. So I'm going to go ahead and I'm going to create my 2/3 before we go any further, and I'll shade this one in. Oops, sorry for that little squiggle on the outside. And I'm going to create 3/4. Since they put it horizontally on the second one, I'll do that too. 1, 2, 3, shaded out of 4. When considering the factors of 3 and 4, the common factor that I could use as a common denominator, or I guess common multiple, 3, 6, 9, 6 and 9, 4 can't go into, but 3 can go into 12, and so can 4. Well, 3 times what gets me to 12? 3 times 4. Conveniently, this denominator. And if I do this on bottom, I must do it on top. So 2 times 4 is 8. Down below, if I want to get to 12, I have to multiply 4 by 3, which means I need to multiply the numerator as well by the same as the denominator. So 3 times 3 is 9. And before I even represent this in the area model, I could pretty much predict what my answer is going to be. But we are obligated to finish all of our work. So I broke it into 4 equal groups, 1, 2, 3, 4, which gives me a total of 1, 2, 3, 4, 5, 6, 7, 8 out of 9, 10, 11, 12. That's what's represented here. In this one, I'm going to take this 3/4 and break it into groups of 3 to make it equal 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have the same size pieces. I know they don't look perfect, but they're pretty close. And when I count, I have 8 pieces out of 12 and 9 pieces out of 12. And the equivalent fractions then, we know that 9/12 is larger than 8/12, so that means that the equivalent of 9/12, 3/4, is larger than the equivalent fraction of 8/12, which is 2/3. So, as we read from left to right, 2/3 is actually less than 3/4. On the back side, I know it's a little messy with some writing on there, but what we have here is renaming fractions. You may use multiplication to compare each fraction by writing greater than, less than, or equal to. The whole goal is how do you get these fractions to represent common denominators? So if I have, I'm just going to rewrite it for spacing, 3/5 and 5/6. Sorry, I'm using the same color. What is a common denominator between 5 and 6? Well, you can actually always multiply each denominator together. So 5 times 6 would be 30. That way I know that I can share that denominator. How do I get from 5 to 30? Well, I multiply by 6. 5 times 6 is 30. Whatever I do down below, I have to do up top. So 3 times 6 is 18. Looking at this one, how did I get from 6 to 30? Well, I multiplied by 5. Whatever I do down below, I must do up top. 5 times 5 is 25. When comparing, I know 25 thirtieths is larger than 18 thirtieths, which means the equivalent fraction of 5/6 is greater than 3/5. Let's look at one more. So I have 7/5. I have a improper fraction, and I have 10/8. Well, what is a shared denominator between 5 and 8? Well, I could just multiply each other. So 5 times 8 is 40, and 8 times 5 is 40. Okay, I have my common denominator now. I have to multiply the numerators by the same values. So 7 times 8, right, because it was 8 for the 5, we increase both at the same rate. 7 times 8 is 56. 10 times 5 is 50. So when I compare these like denominators, I can tell that 56 40ths is greater than 50 40ths, which means my equivalent fraction, 7/5, is greater than 10/8. Now I will tell you, if your numerator was greater than the denominator and this was less than the denominator, then you might not need to find a common denominator, but it doesn't hurt. Use any method to compare the fractions. Let's look at these two. And I really like this common denominator, so we're going to continue practicing it. So 6/8 and 3/5. What would be a common denominator? Well, let's multiply 8 by 5 to get us to 40, and 5 by 8 to get us to 40. When I do that, I must multiply what I did down here up to the numerator. So 6 times 5 is 30, and I multiply the numerator by 8 for this one, right? I'm just increasing this by the same amount and this by the same amount. So 3 times 8 is 24. When I look at these like denominators, I can pretty quickly tell that 30 40ths is greater than 24 40ths, which means the equivalent fraction, 6/8, is greater than 3/5. Let's look down here. I have 8/5 and 9/6. Well, a shared denominator could be 30. 5 times 6 and 6 times 5. So whatever I did down here, I must do to the 8. 8 times 6. What's 8 times 6? 48. What's 9 times 5, right? I did the denominator times 5, so the numerator, 9 times 5. It's going to be 45. Now when I'm looking at like terms, which one is greater? Well, I can pretty quickly tell that 48, not a huge difference, but 48 30ths is greater than 45 30ths, which means the equivalent fraction, 8/5, is greater than 9/6. This last problem I think is pretty interesting, and we have talked about a few ways that you could compare fractions. The first, most obvious, is if it's already a common denominator, whichever has the larger numerator would essentially be the larger fraction. Also, if you're sharing the same numerator, you could also identify whichever is the smaller denominator, because that means each piece is larger. And the last one is you can find common denominator and represent it either in area models, you could even do it in tape diagrams or timelines, or just the numeric multiplication of finding the common denominator, increasing the numerator by the same amount as the denominator, and see which ends up with a larger numerator. Now, what happens if the numerators are the same? Well, that just means it's an equivalent fraction, just in a different form.